Hello all, I'm Alok and today we are going to install Kubernetes cluster using the hard way, the tougher approach. The previous video we have installed the same Kubernetes cluster using kubeadm tool. Kubeadm tool provides us facility to install the cluster very fast, in which all the Kubernetes components are installed and administered using the kubeadm. We just need to provide a few of the details there and your cluster is ready. But in the hard way, we need to install each and every binary of each and every component of Kubernetes by ourselves and set up all the certificates and do the relevant administrative work and create the cluster by our own. So that is what we are going to do today. So let's see what is the structure of the cluster we are working on. So we have two masters, that is master 1 and master 2, and we have two workers, worker 1 and worker 2, in which all these components like etcd, API server, scheduler, controller, manager, kubelet, kubeproxy, haproxy and kubectl, all these components will be installing using the binaries in our cluster and will do the complete setup by our own. Now to follow this demo, you need to go to the VirtualBox and install VirtualBox for your own OS. Also you need to install Vagrant, which is the latest version 2219 or any of the relevant among to and you need to install the you need to pull the GitHub repository, which is github.com/imaginecloud, and if you go on this page you will see one of the repositories called as Kubernetes. In this repository you will see the setup KTS folder. Here we have two folders, the hardware and the vagrant-kubeadm. Vagrant-kubeadm is the installation of Kubernetes cluster using the kubeadm. This one I have already demonstrated in previous demo. I'll share the description of that video, and also you can see the I button above. Today we'll be installing the cluster using the hardware. So this is the folder that we'll be using, and we'll be following all the steps here which are given to install the cluster using the binaries. To install the Ubuntu virtual machines, we are using Vagrant file, and this Vagrant file will install 5 virtual machines in our local environment, in which 2 master nodes will be there, 2 worker nodes will be there, 1 load balancer VM will be there, and 1 administrator VM will be there. And all this configuration that I'll go through in some time. So to follow this demo, let's start cloning this repository first. Let's go to Kubernetes, copy it, go to your favorite IDE. Here I have already installed or pulled this repository Kubernetes. Let's delete it. Clear ls cd ls. Okay, trash cd. Okay, I'll just do this and delete the current one and start. So there is nothing. So now let's git clone and the GitHub repository that we have just copied, paste, enter, and you'll get the Kubernetes repository here with the setup KTS and the hardware. So this is the Vagrant file that we'll be using. Let's quickly start installing the virtual machines. To set up, we need to hit command Vagrant up and enter. Okay, this is not the current directory. Ls, we are not in the right directory. We need to reach to the vagrant file directory, which is in setup kts slash the hardware cd setup cd kubernetes setup kts the hardware ls. Okay, here if you do vagrant status, you should see status of 5 machines, but those are not created yet. To master, to worker, load balancer and admin VM. Let's hit vagrant up to start installing those machines in our local. If you see in VirtualBox, this is coming up master 1. These 3 were the previous VMs, just ignore those. Right now master 1 is getting provisioned, and likewise we'll have master 2, worker 1, worker 2, load balancer and the admin VM. Okay, let's go through the vagrant script. What all we have: the first block of the master nodes, both the two master nodes. This is the number of master node which I'm looping over, and setting up 2 GB of RAM and 2 CPUs which are required for master. Then setting up the IP address, setting up the port for SSH, and the first provisioning script is initial setup. In Ubuntu, initial setup is basically installing the Docker in the virtual machine. Then setup host. What setup host is doing is it is adding the DNS for the other VMs, so that I should not call the VMs using their IP address but using their DNS names. So I'm adding that part here. A part of it, we have the update dns.sh, in which I'm just setting up the DNS inside the resolve.conf to 8.8.8.8. You can see here in resolve.conf all the traffic will go from the 8.8.8.8. Now setup SSH is another provisioning script. Setup SSH, what it is doing, it is adding private key and the public key to each and every VM. Why this is? Because I want connectivity from especially admin VM to each and every other VM, so that I should be able to transfer files from admin VM which will be creating there to all the master nodes, all the worker nodes, and even the load balancer node. So interconnectivity between all the 5 VMs is achieved using this script. Let's go ahead, where this is the setup of the worker node, in which 1 GB RAM and 2 CPUs I am giving to the worker. Setting up the host name, setting up the IP address, then forwarding the SSH port. Initial setup we have already seen, which is installing Docker, and setup host, which is setting up in etc/host file all the references. Then update DNS is for 8.8.8.8 in resolve.conf, and setup SSH for interconnectivity. It is exactly same like the master. Whereas the third one, which is the load balancer, is a bit simpler, in which I'm giving memory like half GB and only 1 CPU, because here we'll be only installing HA proxy, and that is a bit lighter than the other two. Then setting up the host name, setting up the IP address, forwarding the port, and only setup host that is required. Then update DNS and setup SSH. Here we are not doing the here we are not installing Docker. And same with the admin VM, very basic, 512 GB sorry 512 MB, half of GB RAM and one CPU there, and rest of it is common. And this script would take around 5 to 10 minutes time dependent on the speed of your hardware. Currently it is installing master 2. If we can see here in VirtualBox, master 2 is getting provisioned, so we need to wait to install again worker 1, worker 2, admin and load balancer VM. This might take a bit of time, so I'll pause the video here and then resume when the installation is finished, so that we'll resume there. Okay, so now all the VMs are provisioned. Let's see the status. Okay, let's see Vagrant status. All the VMs should be up now. Vagrant status is showing all the VMs are up and running. Now let's follow the readme file of setup the hard way. Setup multi-master Kubernetes the hard way. The first step is setup VM master worker node. Okay, Vagrant up, we just did. Now Vagrant SSH admin. To get into the admin VM first, what we are trying to do is install kubectl in admin VM. Okay, so first get inside the admin VM using Vagrant SSH admin. So its IP address is 56.40. You must use a kubectl version that is within one minor version difference of your cluster. So because we are installing a cluster of version 1.22, so the client should be 1.22 or one version less, 1.21, or one version more, that is 1.23. so we are exactly downloading the same version, that is version 1.22. Let's download the kubectl binary. Here if I see Ctrl+C clear ls, let's do the full screen. Clear ls, there is nothing. Let's download. Okay, so you can see the kubectl binary is present. Let's change the mode of the binary to be an executable one, and then move it to the local bin directory so that we can access it from anywhere. Verify that the kubectl command is working, and let's verify the client version. It is 1.22, the same version of which we are installing the Kubernetes cluster. If we see the configuration of Kubernetes right now, we didn't do any of the configurations yet, so there should be no configuration set, everything is blank. But in the next steps we'll be setting up the configuration once we'll complete installation of the cluster. Okay, now the third step is provisioning a CA certificate and generating the TLS certificate for all the components inside the master node as well as the worker node. Okay, the kube API server certificate requires all names that various components may reach to it. So we need to add all the DNS names and the IP addresses the API server is called from. So because if we create the SSL certificate from command line, we cannot give multiple options which we need to give for a few of the certificate. Hence we are creating the openssl.cnf file, and we'll be using this file during the configuration of this certificate. So what we are doing here is we are adding all the DNS and the IP addresses for the Kube API server certificate here. Okay, the first DNS is kubernetes.default. These are all the names, all the different names Kube API server will be called from. Cluster.local, this is 10.96.0.1. this is the DNS server IP address which will be configuring at last the core DNS, the IP address of the master 1, the IP address of master 2, the IP address of load balancer, and of course the local host, right? And the same stuff we are doing, we are creating the OpenSSL for the etcd, which is our key value pair database. For that as well, we need to have the SSL certificate, and we need to provide the IP addresses of 56.11, 56.12, which is the etcd or the master IP address server. Then we are generating the CA and TLS certificate, in which let's go through it. First we are creating the certificate authority. This is the authority which will authenticate whether the certificate is valid or not in each of the components. First we are creating the authority. This is for our local. So OpenSSL create the key file, providing the key file while creating a new ca.csr, that is another file, and then creating the ca.crd, which is a certificate file in which we give the csr file as well as the key file. Okay, so this is the certificate authority. Then we are creating the admin certificate. While creating the admin certificate, first we are creating the private key, and using the private key and specially giving the name as admin, and my system is master. This is required in particular while creating the certificate. This varies for each and every certificate, and creating the CSR file. Okay, so now we are using the admin.csr file and admin.key file eventually to get the admin's certificate, which is valid for like 1000 days there. Same stuff for the controller manager. We are doing controller manager.key, and eventually we are creating the CSR file for controller manager using the key. The CN name is system kube control manager, and our system is kube control manager. This is the validation the Kube API server will do while validating what kind of access this is requesting, so that we are providing in the certificate, and eventually creating the certificate CSR certificate for Kube Control Manager. Same way we are doing for Kube Proxy, Kube Scheduler, and then the Kube API server. In Kube API server, the key creation is same, generating a key creation, and then for the OpenSSL or CSR, we are giving the configuration which is openssl.cnf, which we have created in here, right? We have provided all the DNS and the IP addresses which are required for that. Okay, so this is how we provide it, and then creating the certificate eventually, ca.csr, and here also we are giving the openssl.cnf file. Same stuff we are doing for etcd, which is the key value pair database of Kubernetes. CN name always varies, etcd server and the OpenSSL. Here we are giving the openssl-etcd.cnf, which is this one. Okay, so and the service account, definitely for that as well we are using the same structure. So after that we are moving the CA certificate and CA key, Kubernetes API server key and Kube API server certificate, service account key and service account certificate, and same etcd certificates to master 1 and master 02 from the admin VM, because all these things, all this creation of certificates we are doing in admin VM. So from there we are moving it using the SAP command to the master 1 as well as master 2, because master and master 2 will work in cluster for the load balancing. Okay, so let's go. We have already SSH'd into admin. We need to set up the OpenSSL first. Okay, now let's create the OpenSSL.cnf, which is created. ls get openssl.this, which is right, clear. Now let's go and create the same for etcd, and now create the all the certificate at the same time. Okay, we'll see. Okay, all the certificates are created and you can see the certificate lists over here. And let's move the certificate to master 1 and master 2. First time it will ask to do SSH. I'll say yes to both the connection. Okay, all the files are moved. To validate that, let's go to another terminal. cd setup Kubernetes setup and the hardware vagrant ssh master 01. So here for the reference of, I'll just rename this to master 01, and this is our admin. Okay, getting into master 01, which is ls. Okay, 5611, you see this is value 56.11, which is the master 1 IP address here. Here all my certificates are been pasted from admin VM as we have requested. Now let's validate master 02. cd Kubernetes setup the hardware vagrant ssh master 02. Now we'll rename this to master 02, and here as well we see the certificates are present. Okay, so step 3 is completed. Now generating the Kubernetes configuration files for authentication in admin VM. So here we are trying to set up the Kubernetes kube config files for kube proxy as well for kube control manager service. Okay, each kube configuration requires Kubernetes API server to connect To support high availability, the IP addresses are assigned to the load balancer. Will be used in case this. So this is the load balancer IP address that we'll be using. Eventually, in after the cluster creation, as we have seen here, all the Kubernetes or all the client or kubectl, everything will connect to the master via the load balancer, which is HA proxy, and HA proxy is having the IP address of uh, 56.30. Hence all the configurations are set with this server 56.30 and the Kube API server port, which is 6443. Okay, setting up the environment variable first. So let's go ahead and set up the environment variable. This has to be done in admin VM. So let's go to the admin VM, clear setup, and then generate the kube proxy certificate. Cluster is created here. If you see kube proxy, cat kube proxy dot config. Here you see the cluster and the user, everything that we have set for this particular cluster. Right now it won't work because we don't have the master set. We'll just keep it at the right position and then we'll be using it. This is same way for the kube control manager. We are giving all the access to the kube control manager and providing all the particular SSH keys to it, so that it will be able to access the kube API server. So okay, ls this kube control manager, oh sorry, .conf, where is it? ls-lht. We have created kube proxy. Okay, kube control manager, this one is not created. We'll try to create it once again, and ls, and now we can see kube control manager proxy. Okay, that is perfect. Now for the kube scheduler, because kube scheduler has to connect to the kube API server as well, so it also needs its own configuration, and we have already given the CA certificate and the scheduler certificate to it, and we are just creating the kube configuration for accessing the kube API server. And this is for the administrator. This is particularly for the admin, that is our kubectl, and that means outside the cluster. If you want to connect to the cluster, we would be using this configuration. And now we are moving the kube proxy configuration to the worker 1 and worker 2, because in worker node only we have the kube proxy and kubelet is also there. Okay, so let's distribute the same last we have created for the kube admin. We have already created for the kube admin. Okay, let's distribute the certificates. Yes to worker 1 and yes to worker 2 as well. Okay, now distribute the Kubernetes certificate to the master. For master, we are moving the admin, controller, manager, scheduler, all the certificates to the master. Let's do the same. Now it won't ask for the permission, it will just pass into the master. Okay, so ls, now you'll see the kube configs for the controller, manager and scheduler as well. And let's access cd worker o1, which is setup and the hardware, and vagrant ssh worker o1, and rename worker o1. And here if we see, the kubeproxy.config file is already present, which we just copied, and this is also for the worker 2. cd kubernetes setup the hardware vagrant ssh worker o2, and this is my worker o2 access, and here as well we see kubeproxy. So it's perfect. Let's generate the encryption key. Exactly why encryption key is used? Because we are using so many secrets, creating the secrets and all. So for that we require the encryption key. Kubernetes stores various data including the cluster state, application configuration and secrets. To store the data encrypted format, we require the encryption key. So we need to generate the encryption key. We are doing this again into the admin VM. Let's generate the encryption key. Verify the encryption key if you want. Let's verify it. Okay, it is created. Generate the kube configuration, which is encryption configuration. Kind is encryption configuration. Here you see it is a special kind which we are trying to create, and we are replacing the encryption key here, and then we'll be moving the encryption key to master 1 and master 2 here. So if we just validate, here we have the encryption key as well. Okay, now we go and bootstrap the etcd cluster. etcd is nothing but the key value store. Right now we are creating like two instances of the etcd cluster, and those are installed in master 1 and master 2. There are various strategies in which the Kubernetes etcd cluster can be maintained. It can be outside master 1 and master 2. We can use another 2 or 3 VMs and create its own cluster there. That means if one master is down, my etcd replication cluster won't downsize there. So right now, because we already have 5 VMs, so we are managing the etcd cluster in the master VM only. Make sure to perform this step only on master VM. So these steps we have to do in master VM. Kubernetes components are stateless and stored in cluster state in etcd. Yeah, we'll bootstrap 2-node etcd cluster and configure it. So verify which etcd version is supported with the Kubernetes. So why this step of verification? First is etcd is not maintained by Kubernetes. It is a third-party component which is being used. So every Kubernetes release which is given, it is download GitHub. If we go to the GitHub release page, let me see. Okay, so these are the Kubernetes release binaries, and these are the source code. So here you won't find the etcd binary. So here only we get the reference which particular version is compatible with the Kubernetes version. So to validate that version of etcd, we need to see we need to pull the Kubernetes binary, which I've just shown you. We need to download it, extract it, and then validate the etcd version. Okay, so this is just the validation step, particularly which version of etcd we need to download. So let's go to master 1. Right now we are here. Clear, pull, it has pulled it. Now it is the binary. Extracted, clear ls, cd kubernetes. You see the client, cluster, doc, hack, and the server. So to extract the etcd version from the hack/lib/etcd.sh, I'm gripping for etcd version. So the version, okay, cd dot dot cd dot dot ls cd. Okay, I got one level up, ls, and okay, now this is the right path, kubernetes/hack, and here you see the version which is compatible is 3.5.0. so now we are confirmed which version we gonna use. Okay, so this is the patch version, so that's totally okay that we can use. So let's download the etcd binary in all the masters. So all these steps below has to be done in both the masters. Okay, as we have two masters, so we'll be doing the same stuff in both the master. First we are downloading the binary of etcd. We'll go to master 1, let's download it, go to master 2 and download it. Okay, and then we need to extract the binary and move it to the bin location so that we can access directly from anywhere from the environment. So on master 1, extract and move, master 2, extract and moved. Okay, now creating the lib folders to keep the keys required. So this is all the keys that we have copied from the admin folder and making a directory which is required by the etcd during its installation. So both the things we are doing. Then extracting the IP address. So etcd is opened on a particular port on a particular IP address. So which IP address it should be? It should be the internal IP address. So I'm pulling the internal IP address and setting it up for the name of the server. So going here, so the IP address is this 56.11, which is my master 1 IP address, and the name would be master 01. For master 02, my IP address is 56.12 and the host name is, or the etcd name is master 02. Okay, so creating the etcd service in all the masters. So here actual service will be created in system d/system/etcd.service. okay, so here the name is given etcd.name, which we have set up here, which is master 1 and master 02, providing all the related certificates here, including the CA certificate, the internal IP address, and also I'm giving the cluster, initial cluster. That means because this is the point where it understands that it's not an independent etcd instance, it is a cluster, and these are the two instances which has to be acted upon within the cluster. So let's use it. This has to be in both the masters. Let's start. Just created, and here it is created, not yet created, we have just created the file. to validate if all the variables which are set are correct. Okay, all the variables are properly replaced. We cannot see any of the errors in the file. Same in master 2. Yeah, it is validated. Now we'll just refresh the environment variables, enable etcd, and then start it. So we'll go to master 1. It is started. Master 2, it is started. Let's validate the status of it. Master 1, you see it is active and running, and apparently there are no errors in the log. And master 02, here as well it is actively running. Okay, optionally check the log files if at all you want to see the complete log files continuously, what exactly happening. Maybe if at all it is not working perfectly, you see some of the errors or the state is not active, you can see the logs using this command and it will continuously see the logs. Right now all the logs are quite stable and apparently there is no issue here. But yeah, this is how you can see the logs of the etcd service. Verify the list that it is actually the etcd cluster is working in cluster mode or not. So this command will list all the etcd members in the cluster. Apparently yes, both the members are working and active. Its name are master 01 and master 02, and yeah, these are the ip addresses and this. So yeah, I guess it is working properly. Now let's bootstrap the Kubernetes control plane. Control plane, that means API server, scheduler, and controller manager. These are the control plane components. So in both the master 1 and master 2 we need to install these two. Okay, so let's first create the configuration directory in both the masters. So let's go here in master 1. Okay, we are looking at this. Control C, clear, creating the configuration directory in both clear and creating the directory. Download and install the Kubernetes control binary in all the masters. So I'm using wget to pull the binaries. All are version 1.22.0. We are just keeping the same version which is used for kubectl. So we are using the Google API download link and pulling it. So it is the Kube API server, controller manager, Kube scheduler, and also kubectl. So all these things we are pulling up in master 1 and master 2. Let's go to master 1, download it, master 2, download it. Okay, once this is done, then we'll change the mode and move it to the local bin directory so that we'll be able to access it from anywhere in the workspace. It is still downloading. It is taking a bit of time. Apparently it is a bigger file. Okay, so next what we'll be doing is creating a few of the directories which are required for setup. So all the files will be moved to libs as Kubernetes, and during the setup file, which is here, this is the Kube API service set file. This is the biggest file, configuration file, if I say, among all the control plane components. So this folders will be referred during the setup. to access the certificates. Hence we are doing the pre-setup there, so that we can keep everything there. Okay, etcd server, how many servers do we have for etcd cluster? We are giving here. API server is the only component which can connect to the etcd server. All the other control plane components, maybe the worker nodes or the outside kubectl or the admin, everything will go through the Kube API server to connect to etcd. It's not directly connected to any other component, so we are providing the etcd access over here. The encryption configuration that we have used, the ca file, the this is the ca file, encryption file, Kube API server certificate, all the configuration, the cluster IP range. So this is the IP range that will be used internally when we'll be creating the services, the node port services 3000 to 32767. This is the range of the port that will be used. Everything we can configure practically from here. Let's see. Okay, in both the system it is downloaded. Let's go and create the required configuration and move it to the bin directories, create the required folder and move the certificates to the right folder. I need to get the internal IP address as the environment variable, so that my scripts here would use those internal IP address whenever required as the advertising IP address. Okay, I'm copying the entire this in master 2, also in master 1. Okay, and similarly we are setting up the controller manager service. Now copy the controller manager service to the configuration to the lib, just the way we did for Kube API server, and also do this in master 2. Set up the controller manager service in master 1 as well as in master 2. Yet it is started, it is yet to start. Move the kube scheduler configurations. For this is the kube scheduler. We are doing the same stuff. Creating the service files, and now we are refreshing the environment variable, enabling and starting the services. So created the symbolic link, that means it service is created. Now to validate, we can validate the component status. Let's give it 5 seconds to make sure it is working and healthy. Now if I go to master 1, let me clear and then see the component status. Now you see the scheduler is healthy, controller manager is also healthy, and both my etcd 1 and 0, both the clusters are also healthy and connected to the master components. Okay, so apparently this is good. My control plane components are also set up, those are connected to the etcd cluster as well. Now let's move to the load balancer VM and install HA proxy into it. So first I'll get into the load balancer VM, cd Kubernetes, set up the hard way vagrant ssh lb for the load balancer, and here rename always I rename and just fix my name. Okay, it is LB. Okay, perfect. Okay, so it is very simple. We are using the basic commands to install the HA proxy into the load balancer VM, and then creating the configuration files in etc haproxy.conf. So my front end, that means the request coming to the load balancer IP address colon 6443. This is the IP address of the Kube API server. So where to forward? To the default backend. What is the default backend? The backend is Kubernetes master node. So it is forwarding into round robin fashion to master O1 whose IP address is this, and master O2 whose IP address is this. So this is the configuration that will be setting up, then starting this service and then validating the service. Okay, let's go and install the load balancer HA proxy, updating, installing the HA proxy. Then I need to create the configuration. Let's wait. Okay, this is done. I have created the configuration, and then let's start the service, and let's validate the service. Okay, so the service is active, and to validate whether actually the service is working or doing the load balancing, let's check the version of the Kubernetes through the load balancer IP address and the port of the Kube API server. Q clear. Okay, so using the load balancer IP address, I'm able to connect to one of the master. So it is load balance. So I'm not sure anyone of the two master is been invoked. So I guess the load balancer is also working and healthy. Now let's move towards the setup of the worker node. In our setup, worker node is consist of the kubelet and kube proxy. Kubelet is always communicating to the Kube API server to give all the status of the pods which are running here, give logs, and also whenever a new request is scheduled to create a new pod, it communicates with the underlying Docker or Rocket, whichever containerization tool is installed, and it requests it to run that container. So these are the two things which are installed in worker node. Let's generate the keys on the administrator VM. Which are the keys? Again, the OpenSSL keys here, because we need to provide the DNS and the IP address both. So for both worker 1 and worker 2, we are creating the OpenSSL keys, and this has to be done on the admin VM. Okay, let's clear this up and create the two configuration files, and the same standard way we are creating the worker 1 private key, and then when creating a CSR, and then we are creating the CRT file and providing the OpenSSL worker 1 and worker 2 here. Okay, so this will create, and these certificates will be valid for 1000 days, and for now we can just configure it as we want. So let's create both, and if we do ls, we see worker 1 keys are created. Okay, now generate the kube configuration files, because it has to connect to the Kube API server again. So it should have its own special Kube configuration file, in which it has to be clear that it's a node type. So it will get all the access of a node. Okay, so that is differing in each and every kubectl configuration. So let's create the configuration for worker O1, and this is for worker O2. Okay, both the configuration files are also created. Now move the worker O1 and the kube configuration files to first worker O1, and same stuff, let's do it for the worker O2, so that we'll have these files present in the worker O1 and worker O2. Yes, it is there. So now downloading the kubectl, kubeproxy and kubelet, as we have expected. Kubelet, kubeproxy and kubectl, practically we won't use it, but yeah, we are just keeping it downloaded, and for the access we are keeping it there. So this has to be done on each worker node. Okay, so I'll go to worker node 1, I'll download all the binaries. In worker node 2, I'm downloading the binary. Okay, again making multiple directories for CNI, bin, kubelet, kubeproxy, Kubernetes, and var run Kubernetes. These directories will be used again beneath for the services, and keep accessing the certificates from those locations. For that we need to create those directories. Let's wait for the binaries to be installed. Till the time, let's see the Kubernetes kubelet service. The kubelet service, we have the kubelet configuration, which we'll be creating above, and then we are setting the host name, we are setting up the key and the certificate both into it. Then the network plugin, which is CNI. This is for the kubelet, and same way we are the kubeproxy. Kubeproxy is required for the networking between the pods in each and every worker node. So that is also, so we are giving the CIDR, that is the IP addresses given to the pods. So that is kubeproxy configuration, and this is the kubeproxy actual service. Okay, so as it is downloaded, let's go back and create the folders first. Go to the worker 1 and then worker 2, then changing its mode and moving it to the bin directory, as we have done this for the other component as well on master. Then moving it the key files, that is hostname is worker O1, so worker O1.key, worker O2.key, those will be moved to the kubelet. Let's do it on worker O1 and also on worker O2. Okay, now create the kubelet configurations. Okay, where configuration is resolve.conf. That means every time a pod will be created, it will replace the resolve.conf and put the IP address of the DNS over there. That is the reference. So that we are doing on both the worker nodes. After creating the configuration, let's create the kubelet service. So I'm moving the kubelet service configuration file to system D of both the workers. Then same way create the configuration file, first moving the file into the kubeproxy slash kubeconfig, and then creating the kubeconfig.yaml in both the worker. Now creating the kubeproxy service file, and now we'll be refreshing the environment variable, enabling and starting both the services. Fail to enable unit kubeproxy service does not exist. Kubeproxy service does not exist on one. In this both it worked. So kubeproxy service, this is the kubeproxy service which is here. Let's try to enable it. Okay, now it is enabled. That service was not properly pasted. Okay, so the symbolic link is created on both. Let's see the status, whether the kubelet service and these services are working perfect. Okay, kubelet is working fine on worker 1. Let's see on worker 2. Yes, it is working fine, but if you see the logs of kubelet on any of the worker node, it will keep on saying that there is an error, no network found. This means it is searching for the network solution, and we have yet not installed any of the network solution. We'll be installing it afterwards, and then only this error will go. Right now it is unable to find it. Okay, for the kubeproxy is also working well on worker 1, and control C, and on worker 2 as well it is working well. Okay, this will just show you the kubeproxy logs. Let's see, after enabling the kubelet service on both the worker nodes, now if I validate, I should see the worker 1 node 1 and worker node 2. These two nodes has to be shown on the master 1. As expected, we can see worker node O1 and worker node O2, but the status is not ready. It is not ready because we have already seen the kubelet service is showing that it cannot find any of the networking solution until the time it is not ready, and hence the status is not ready here. Never mind, we'll be installing the networking solution by into it, and then we'll be validating and to see the status changes to the ready state. Okay, now let's configure the admin node for the kubelet kubectl configuration, so that this is regularly whenever a developer would get the access of Kubernetes cluster, it will have the kubeadm config, that is kubectl config. This configuration now will set up in the administrator node. That means so that we'll be able to access the cluster from the admin node. So we need to do the setup, and here if you see, the type would be the admin type. Just a minute. Okay, yeah, the credential set for the admin here, and the user is also the admin user, so that we'll be able to access from the admin node. So now here we, from the admin node, we don't need to provide the configuration file just the way we provided from the master node. If we go to the master node, and we have seen, you see kube configuration, we have given the reference of the configuration file. uh, because it was not by default set in master 1, but in admin, because we have given just now the access where the default configuration file. So now we can see the same status but without giving the reference of the kube configuration file. So that is setting up the admin kubectl. Now set up the container networking, so that we'll get a working state of our nodes. So we'll be deploying the Calico network from the admin node. Okay, so there are two steps. First has to be from the master 1 and master 2, that is from kubectl. So this part we can do from the admin node because it is now configured to connect to the cluster, the admin node. And second part is to install the CNI plugin in all the workers. So let's do the first part. We are on the admin node. We'll be creating the admin config and creating the Calico network. So this is the reference YAML file in which all the setup of the just a minute, cat kubernetes admin.conf. This file has to be present. Let me see what is wrong. Okay, kubectl, okay, network is this on admin VM. Let me install this without the kube configuration. Okay, if I just the way we have given the kube config file over here, if I don't want to give the kube configuration files, without that also it should run because we have already set up the default configuration to kubectl the right way. Okay, now it has created the connection here. Be updating this and then installing the CNI plugin in all the worker. So for this worker, okay, before installing the CNI plugin, if we check the status of the node, it is still not ready. That means in master 1 and master 2 we do have the nodes pods running. Kubectl get pods, alas, kubectl, okay, get pods, kubectl get pods minus n cube system. Here you see the Calico network pod is initiating. That means the pod is creating here. Anyway, still the status of the node won't be there. Okay, it is already because the network is already set up. So yeah, that is great. But we need to add the CNI plugin in worker 01 and worker 02 so that it will be able to access to the network which is created into the master 1 and master 2. Okay, downloading the binary and then extracting both the binaries. Okay, kubectl get nodes we have already seen. It is, yes, it is working and it is into the ready state. Kubectl get nodes minus o wide. You can see the Ubuntu 18.04 which we have installed from Vagrant. The IP addresses of the worker node 56.21 and 22, which is set. The Docker version is 20.10. Yeah, apparently it is working good and it is stable. So one of the steps that has to be done is giving the authorization of Kube API server to the kubelet. This is the reverse, because if we try to get the logs of any of the pod, we won't be able to get the logs, and it will, though the logs will be in the running, the pod will be in running state. If we try to pull the logs of that pod, it will say it is forbidden. um, it is unable to access the logs. This is because we have given all the certificates on all the access from all the control plane component to the Kube API server, but the reverse, that is Kube, whenever the Kube API server would request the kubelet on worker 2 to pull the logs, it has to be authenticated as well. For that, we need to create the role and the role binding, that is the cluster role and the cluster role binding, and let it know that it is a Kube API server to kubelet, Kube API server to kubelet. This is very important, again, in terms of the RBAC that we need to set up. So if we want to see kubectl logs, the net, this will be different, but then -c, you'll be expecting this error. Okay, let's do it. I'm on my master, but right now kubectl get pods -n cube system. So we have the Calico network here. So here, if we do kubectl logs, kubectl logs, we don't have the Wave network, we have the Calico network installed in here. So I'll do the Calico -c, we don't have it. If it is a multi-container pod, then we might not be knowing. So let's go kubectl, we need to kubectl get deploy -n and kube system, Calico kubectl describe deploy, and this deploy -n kube system. Let's see the container. The container is containers Calico Kube controller. This is one of the container that we can pull. Okay, and we go where we are pulling the logs -c -n cube. This Calico is not a valid part of Calico. This, okay, deploy logs get pods. Okay, Calico node this. Okay, let's not give the -c, there is no multi-container it's in. So you see it is forbidden and it is unable to pull the pods logs. Okay, so let's create the cluster role and the cluster role binding for the Kube API server to kubelet. It has to be done on each of the, no, it don't need to do on each of the worker node. We can do it on the admin node as well. So from admin node only, if I create both the cluster role and cluster this, we should be able to do it. Container, we have created Calico. Okay, and let's validate the logs once again. This is the logs. Now you can see the logs. That means the cluster role and cluster role bindings are working well. We are able to see the logs. Okay, this is how we have validated. This document is showing with the Weave network, but we have used the Calico network. It is totally okay. Now deploying the busybox image just to validate if things are working, deploying the core DNS cluster add-on. So core DNS cluster, this is the internal DNS in the Kubernetes cluster that we have to do. That is what we are trying to install here. We are installing the busybox pod just to give you the glance of how it behaves before and after installing the core DNS. So let me clear it, create a pod, kubectl get pods, it is pulling, um, get pods -w. Okay, the pod is running already. If I get into the pod and do ns lookup for Kubernetes, what is ns lookup for Kubernetes? You see, the Kubernetes was one of the DNS that we have set in the Kube API server while creating the Kube API server configurations. Okay, here you see the DNS1 set is Kubernetes and Kubernetes.default. We are just trying to do a NS lookup on this particular DNS, that is Kubernetes. It is step number 13. I'm really sorry to distract here. Okay, so we are trying to do NS lookup for that particular Kubernetes. busybox invalid -ti kubectl. Okay, so it is looking on 10.96.0.10. what is 10.96.0.10? It is the cluster DNS service that is expected to be there, which is not right now, so it is unable to validate. This is the DNS service address, same, but it won't get you to any of the result. So okay, that we'll see after installing the cluster DNS. The controller did not return, that means it is unable to resolve it. Okay, and you can also validate from where the 10.96.0.10 came from, because it is installed in resolve.conf. if I go here, it busybox resolve.conf, you should see the name server used here is 10.96.0.10, which is set by us. This is during the pod creation. Whenever a new pod is created, this is updated. Okay, so let's deploy the cluster add-on. We'll be installing the core DNS. There are multiple other um, options as well to install, but we'll be installing core DNS because it will be used definitely by the Kubernetes in the future as a default DNS solution. So as the output, we should expect a service account created, cluster role binding, few of the config max deployments and the services been created. We are doing this on the admin VM because we need to have access to the kubectl. Okay, let's do it. Okay, these are created. Now if we do the exactly same stuff, ns lookup on the busybox pod, let's expect that it should resolve, and you see it is resolving 10.96.0.1, then from the DNS server he went here, and from here it is able to access the DNS which is set. And I guess this is the end of the cluster creation here. And we have the Kubernetes cluster created using the hard way, all the core binaries that we have used: kubectl, get nodes, -o wide. We see it is working well and healthy. We can increase the number of masters, number of worker nodes as we require. With this script we need to change, do the same stuff that we are doing on this for all the workers and master. We need to just replicate that steps to other masters and worker. So this is what I wanted to show you in this demo. To clean up the environment, what we can do is we can do exit from the admin VM, clear ls vagrant status. The current status is running. So to clear or delete all the machines that are present here, we can do vagrant destroy. Destroy will completely delete all the virtual machines from your system, so you won't be able to get the same state that we are in all the installed. If you want to just shut down the environment for now, for today, because you are doing end of the day, so you can use vagrant halt, HALT, so that from tomorrow when you do again vagrant up, you will get the same state of your Kubernetes cluster. But if you don't want the cluster anymore, you don't want the VMs anymore, you can just do vagrant destroy -f just to confirm. It confirms for all the VMs whether to actually delete or not, and you can just hit enter and it will just destroy. So yeah, this is demo went a bit longer definitely, but yes, the hardware takes it that much of the time, and I needed to actually show you each and every step that we are doing here. And it worked well. All do definitely try installing. This will definitely help you if you are giving the exam of CKA, definitely Kubernetes certified administrator, in which there are multiple questions asked to validate the environment and fix the environment. And if you have the clear idea of what components are dependent on what certificate, where it is located and what is its location, if you practice this setup multiple times, definitely you will get a really good confidence to get into the exam. And if you are doing for the learning purpose, definitely yes, you'll really get a good clarity of the entire cluster. Okay, so this is all I wanted to show. Thank you so much. Thank you for watching. Do like and subscribe. Thank you.